know the story of the Exodus. The Bible speaks of a people enslaved in Egypt, building store cities for the Pharaoh. For centuries, paintings, films, and sermons have shown us this same image. Thousands of Hebrews, under the whip, dragging stone blocks to build the pyramids. It is a scene etched into our collective memory. But then, archaeologists went to excavate where tradition said the labor camps were. And what they found were neither chains nor tears. They were bones, papyri, and villages that tell a completely different story. A story that does not disprove faith, but corrects our imagination. Why does this matter? Because separating historical fact from cultural tradition is the first step toward understanding the true wonder and the true injustice of that era. The question, who built the pyramids, is one of the oldest in the world, and the answer, unearthed stone by stone, is more fascinating than the legend. Today, we are embarking on a journey to understand 7 engineering machines that made the pyramids possible. But before we talk about levers and hydraulics, we need to talk about people, because the first great machine was social organization. The image of the Hebrew slave is powerful, but archaeology simply does not find it at the Giza construction site, which dates back to about 2,500 years before Christ. Excavations led by Egyptologists like Mark Lehner and Zahi Hawass near the Great Pyramids revealed something extraordinary: a city. Not a precarious camp. A planned city with streets, bakeries, breweries on an industrial scale, and cemeteries. And it was these cemeteries that silenced the debates. The skeletons found there show signs of hard work, yes, spinal injuries, arthritis, but they also show signs of healing, fractures that were treated and consolidated. These people were not disposable. They received care, and the records are the records. In papyri like the Diary of Merer, we find meticulous notes, work teams with names like the Friends of Khufu or the Drunkards of Menkaure. They received payment: beer, bread, fish, fabric. It was a form of salary. They were specialized workers: masons, carpenters, ramp foremen, and rotating workers, recruited temporarily from villages along the Nile, fulfilling a kind of civic service for the state, for the pharaoh. So, where does biblical slavery come in? There lies the rift between history and tradition. Slavery existed in Egypt, as in all of antiquity. Foreigners captured in wars could be forced to work. The period of the Exodus, if located historically, is generally associated with a much later pharaoh, Ramesses II, more than 1,000 years after the pyramids of Giza, and the works of Ramesses, great cities in the Nile Delta, like Pi Ramesses. There, yes, it is plausible that Semitic populations, which may include the ancestors of the Hebrews, were subjected to forced labor. But they were cities of mud bricks, not pyramids of stone. The confusion was born much later. The Greeks, like Herodotus, were already hearing legends about the construction. The biblical narrative of oppression in Egypt was powerful. Over time, the two images, that of the Exodus slaves and that of the monumental pyramids, fused in popular culture until the archaeologists' shovels separated them. This shows us something crucial. By shifting the focus away from the myth of slaves, we do not diminish the achievement. We enlarge it. Because what emerges is the image of a civilization capable of mobilizing, feeding, organizing, and caring for tens of thousands of people for decades in a project that defied time. It was a feat of human logistics as impressive as that of engineering, and if it wasn't the brute force of millions of slaves that raised these monuments, then how was it done? What did this organized society create to move mountains of stone? The answer lies in intelligence, and the first demonstration of that intelligence didn't come from a tool, but from a simple idea: using what nature gave for free. And what did Egypt have in abundance? Water. Imagine the classic construction scene: hundreds of men, sweating, pulling ropes on an endless ramp. It is the image we have in our heads. But what if I told you that one of the most recent and boldest theories throws that image out the window? What if, instead of pulling the blocks up, the Egyptians simply made them float? It sounds like science fiction, but that is exactly what a revolutionary theory proposes, studied in depth in 2024, focusing on the Pyramid of Djoser, the first of all, the Step Pyramid. Researchers looked at that structure and asked a simple question: why build something so complex here, far from the river? The answer may be hidden in geography and the purest physics. The hydraulic elevator theory is so elegant, it is almost beautiful. It all begins with a gigantic and little-known structure near the Pyramid of Djoser, the Giza el-Mudir. It is a colossal stone wall, the oldest in the world. For decades, no one knew its function for sure, until the hypothesis gained strength. It was not a fortress, it was a dam, a primitive barrage. The idea works like this. During the annual Nile floods or during heavy rains, water was captured and directed into this system, but muddy water would clog everything. So, Egyptian genius went to work. They would have created settling tanks. The water stopped, the sand and mud settled at the bottom, and the clean water moved forward. To where? To the heart of the construction. Here comes the magic. The theory suggests that inside the pyramid under construction itself, there were shafts or vertical chambers. This clean water was pumped, possibly with some bucket or siphon mechanism, to fill these shafts. Now, think of a massive stone block, tied to something that floats, like a sealed wooden container, or attached to a system of rafts. When you fill the shaft with water, the block, by the force of buoyancy, begins to rise. It is a primitive elevator, powered by water. To place the block in the exact spot, they only had to drain the water slowly from a connected compartment. The block descended with millimeter precision, and the best part, the water was reused. It was an almost circular system. The force did not come from human muscles pulling against gravity. It came from nature itself, domesticated by ingenuity. Of course, this is a theory. It is still being debated, tested with models. But it makes brutal sense when you look at the challenges. Transporting a block of several tons horizontally with sleds is one thing. Raising it vertically is a completely different energy problem. Using water as a driving force would solve the greatest energy expenditure of the construction. And this leads us to a crucial point about the Egyptians. They were masters of hydraulics. They lived off the Nile. They measured its floods, created complex irrigation canals. Mastering water to build wouldn't be such a big leap. It would be the application of their greatest knowledge to their greatest challenge. If this theory is right, it changes everything. The pyramid would not just be a tomb being raised. It would be, during its construction, a living machine. An organism that used water as blood to make its own stone bones rise. The image shifts from one of painful effort to one of an almost organic, silent, and intelligent process. But even if the hydraulic elevator is just a fascinating hypothesis, one thing is certain. The Egyptians did not depend on a single solution. They were pragmatic. And for the problems water didn't solve, they had another answer. An answer that is right in front of our eyes, in every pyramid we see, but that we never quite understood. They are the steps. And they weren't just for the pharaoh's soul to climb to heaven. They were part of the gear. Now, look at any image of a step pyramid like Djoser's. What do you see? A giant staircase to the sky, right? What if I told you those steps weren't the end of the work? They were the tool, the most visible part of a machine that remained hidden for 4,700 years. This is a brilliant theory, proposed by researchers like engineer Paul High. It begins with a practical problem. You've already hoisted a block with a ramp to a certain floor. How do you lift it from the floor of that level to the next step? The classic solution has always been levers. Men with poles, straining to lift one corner, placing a stone underneath, then lifting the other corner. A slow, dangerous job that required immense strength. But what if the Egyptians had invented something more efficient? Something that transformed the very profile of the pyramid into a gear? The theory is this. Each step of the pyramid functioned as a rack. Do you know what a rack is? It's that toothed bar that engages with a round gear, the pinion. It's the principle of a can opener or a manual car jack. The mechanical advantage is enormous. You turn the crank a little and the object moves a lot. The Egyptians, according to this idea, would have created the shedu, a wooden pulley, but not round and smooth. It was a wheel with 4, maybe 6, protruding lobes. It looked like a wooden cogwheel. This shedu was mounted on an axle inside a wooden frame that surrounded the stone block. Imagine the scene. The block is at the level of a step. Workers position the wooden machine, with the shedu resting on the edge of the step above. They then pull ropes wrapped around the shedu's axle. The wooden cogwheel rotates, and each lobe, as it turns, pushes against the stone step. It is as if the wheel were walking upward, step by step, dragging the block with it. The calculations are surprising. With this system, the mechanical advantage could reach 2.8 times. Translating, a block that weighs 2,500 kilos, 2.5 tons, could be lifted with an effective force of only 900 kilos. This is something a team of 10 or 12 men, pulling ropes with rhythm, would be perfectly capable of doing. Suddenly, the Herculean task becomes a coordinated, almost rhythmic job. The beauty of this theory lies in its simplicity and its dual purpose. The step pyramid was not an architectural style that was later perfected into the smooth form. It was, possibly, the functional form. Each step was a fulcrum, a tooth of the larger construction gear. Only after all the blocks were in place were the spaces between the steps filled with the smooth limestone casing, transforming the machine into a pure monument. The tool was hidden inside the work of art. This speaks to us of an integrated engineering mindset. They didn't just think about the final form, they designed the construction process into the design of the building. The pyramid grew, and by growing, it created the means for its own continuation. It was a self-reinforcing organism. Of course, we haven't found a preserved wooden shedu. Organic material rarely survives millennia in the desert. But the theory is plausible. It fits perfectly with the available technology. Wood, papyrus ropes, empirical knowledge of levers. And it solves one of the thorniest problems of vertical construction. If the hydraulic elevator was the grandiose and centralized solution, the pinion and rack system was the modular solution, repeatable on every face of the pyramid. It was the everyday tool. But for these lifting tools to work, the blocks first had to reach the base of the pyramid. And how do you move a mountain of stone across the desert? The answer, once again, came from a deep understanding of the elements. And this time, the key element was under their feet. It was sand, and they discovered that wetting it performed magic. Think of the largest block inside the pyramids. It could reach 60 or 80 tons. That's the weight of a full tanker truck. Now imagine moving that tanker truck across miles of desert, without wheels, without steel, without an engine. Only with wood, ropes, and muscles. It seems like an impossible task, a torture. Until you understand that the Egyptians were not fighting the sand, they were partnering with it. For a long time, Egyptologists assumed the blocks were dragged on wooden sleds over a dry sand surface. Experiments showed it was brutal work. The friction was immense. Hundreds of men per block would be needed, and the wear and tear would be absurd. Something didn't add up. Until a team of physicists and archaeologists a few years ago decided to test a clue that came from an unexpected source, a tomb painting. In the tomb of Jehutihotep, a governor of the Middle Kingdom, there is a famous scene. It shows a colossal statue being transported on a sled. And in front of the sled, a man is pouring a liquid on the ground. For decades, it was thought to be a ritual, a ceremonial purification. But what if it were? Pure engineering. They set up an experiment. They created a scale version of an Egyptian sled and placed it on dry desert sand. They measured the force needed to pull it. Then they moistened the sand in front of the sled, recreating the scene from the painting. The result was jaw-dropping. The force required dropped by half. Why? The physics behind it is beautiful. Dry sand forms mounds in front of any object pushing it, creating a barrier. When you add the right amount of water, a phenomenon called capillarity occurs. Water creates microscopic bridges between sand grains, causing them to bind. The sand becomes stiffer, more consistent. It is as if, momentarily, you transform soft sand into a compacted dirt road. The sled glides instead of digging. They weren't just wetting the sand, they were creating a track. A track that self-repaired as the sled passed, and that could be moistened again further ahead. The amount of water was crucial. Not too much, not too little. And the Egyptians, masters at controlling water for agriculture, certainly mastered this measure. Suddenly, transportation stops being a logistical nightmare and becomes a complex yet viable operation. A team of 20 or 30 men could move a multi-ton block with relative efficiency. And this explains how they brought granite from Aswan, more than 800 kilometers away. They didn't drag the blocks across the entire desert. They used the Nile. Here enters the seventh wonder of Egyptian logistics, which we will explore better later. Boats. Limestone blocks were shipped from Tura on the other side of the river. Granite blocks came by boat from the south. They reached an artificial port built especially on the Giza plateau. From there, the final journey was by land. And it was in this final journey that the wet sand trick made all the difference. The sled itself was a piece of engineering. Made of robust tamarisk or cedar wood, the ropes were made of papyrus, incredibly resistant. They knew the knots, the levers. But the true secret component was the one that seemed most insignificant. A jar of water. This reveals a deep mindset. The Egyptians were phenomenal observers of nature. They didn't see sand as an obstacle. They saw it as a material that could be modified. They didn't see water only for drinking or irrigation. They saw it as a lubricant, a physical transformation agent. They worked with the environment, not against it. So, we have the block in place, at the foot of the pyramid. Water has already played its part in transport. Now, how to lift it? If the hydraulic elevator or pinion and rack theories were the only ones, it would already be incredible. But the pragmatic Egyptians had more than one tool in the box, and one of them was described by a very, very old tourist. A curious Greek who visited Egypt and heard stories that were already legends in his time. His name was Herodotus, and he described a machine that looked like a giant seesaw. Around 450 before Christ, a Greek historian named Herodotus traveled through Egypt. He was what we would call today a curious reporter. He noted everything he saw, and more importantly, everything he heard. And the Egyptian priests, guardians of a history already 1,000 years old at that time, told him how the pyramids were built. Herodotus wrote this down, and for centuries, scholars read his description and thought it was a legend, a Greek exaggeration. Until modern physics looked at the text and thought, wait a minute, this could work. Herodotus described machines made of wood. He said the Egyptians used gadgets to lift the blocks from one step to the next. And then comes the more specific description. He speaks of a device that functioned like a lever, but not a simple lever. It was a system that used a movable counterweight, a kind of giant seesaw. Let's reconstruct the scene as modern engineers understand it. Imagine a large, robust wooden beam, like the trunk of a palm tree. At one end of this beam, you firmly attach the stone block to be lifted. In the middle of the beam, there is a fulcrum, a kind of sawhorse. And at the other end you have a box or a container full of sand. Here is the genius. The heavy stone block is on the ground. The sandbox at the opposite end is suspended in the air, but its weight is not enough to lift the stone. Then, the workers begin to empty the sand from the box. Grain by grain, bag by bag, the weight on the box side decreases. And, by the law of the lever, the side of the stone block, which is now heavier relative to the other side, begins to move upward. It is a slow, highly controlled movement. As the sand comes out, the block rises millimeters, centimeters. When it reaches the height of the next step, Workers quickly place wooden shims underneath it, locking it in place. Then, they reposition the machine for the next lift. The sand that was removed is put back into the box for the next operation. It is a recyclable system that uses an abundant and easy-to-handle material, sand, as the fuel for its mechanism. The beauty of this machine lies in its safety and fine control. There are no ropes that can snap under extreme tension. There is no risk of the block plummeting. The movement is inevitable and smooth, governed by the simple removal of a granular material. Any worker could understand the principle. It was democratic technology. Some skeptics doubted because Herodotus wrote centuries after the facts. But he was reporting an oral tradition, possibly preserved by the craftsmen themselves. And when you combine this description with the pinion and rack theory, you see no contradiction. You see a repertoire. It is perfectly plausible that the Egyptians used different techniques for different situations. Herodotus's seesaw could be ideal for fine adjustments, for placing finishing blocks, or for smaller works. The rack system, for the continuous ascent of structural blocks. This shows us there was no single manual, no lost secret formula. There was a set of applied physics principles and a work culture that adapted the solution to the problem. They were practical engineers. If a wooden sand seesaw solved a lifting problem safely and efficiently, they used it, without complicating things. But all these machines, the seesaw, the pinion, the water elevator, depended on a fundamental raw material, stone. And the stone did not arrive ready. It needed to be extracted from the mountain, cut, carved, drilled. How did a Bronze Age civilization perform surgery on granite, one of the hardest rocks on the planet? The answer doesn't lie in magic metals. It lies in a tiny grain of sand. Again, sand. Here is one of the greatest puzzles of the pyramids. Inside the king's chamber in the Great Pyramid are the granite sarcophagi, a material so hard that today we use industrial diamond blades to cut it. The surfaces are flat, the corners are perfect, the holes for the lids are circular and deep. How? The Egyptians only had copper, and pure copper is a soft metal. You can scratch it with a steel knife. So how does a copper saw cut granite? The answer, once again, is not in the tool itself, but in what they placed between the tool and the stone. And that magic element was the same one that lubricated the sleds. Sand, but not just any sand. Quartz sand. The Egyptians didn't have steel, but they had a practical understanding of hardness. They knew that quartz, a mineral abundant in the desert, is harder than copper. Much harder. In fact, it is harder than granite. So, they didn't use the copper saw to cut the stone. They used the copper saw as a vehicle, a way to carry millions of tiny quartz particles with their razor-sharp tips to scrape and wear down the rock. The process was slow, methodical, and required a patience that challenges our era of hurry. To cut a block, they probably marked a line on the stone. Then, they created a shallow channel along that line, perhaps with dolerite chisels, an even harder stone. In that channel, they placed the copper blade, thick, and added a wet paste of quartz sand. Two workers, one on each side, pulled the saw back and forth, like a giant crosscut saw. With every pull, the quartz grains trapped between the copper and the granite acted as micro-emery, scraping, wearing down, thousandth of a millimeter by thousandth of a millimeter. And the drill? The drill is even more impressive. They used hollow copper tubes, the same principle. The tube was turned, probably with a wooden bow, a technique they used to make fire. While it turned, a helper continuously poured the abrasive paste of sand and water into the slit. The hollow copper tube, under pressure and with the abrasive, drilled through the rock. And the stone core that remained inside the tube? It was removed. In museums, there are granite cores drilled by the Egyptians that show the perfect helical marks of the drill. They are physical proof of the technique. They also had a more resistant alloy, arsenical copper. By adding arsenic to copper, they achieved a harder metal, better suited to maintaining the shape of tools under continuous effort. But still, The cutting force came from the abrasive. This completely changes our perspective. It is not a matter of brute force. It is a matter of intelligent persistence. Cutting a granite block with this technique could take weeks, maybe months, but they had the time, and they had the social organization to maintain specialized teams in this task, while other teams transported, others lifted, and others set. This monumental patience speaks to us of a civilization with a different time horizon than ours. A pyramid project spanned the reign of a pharaoh, 20 or 30 years. It was a project of state, of society. The slowness of stone cutting was not an obstacle. It was just a phase of the process which happened in parallel with all others. And this leads us to a crucial point. All these machines and techniques, the elevator, the rack, the seesaw, the saws, needed to be coordinated. The stone cut in Aswan needed to arrive at the right time. The wood for the sleds and machines needed to be available. The workers needed to be fed. Water for the sand and for the cuts needed to be managed. The true pyramid, the one that supported the one of stone, was a pyramid of logistics. And the brain of this operation was not in an engineering project, but in a logbook, a papyrus that recorded day after day the routine of a foreman. Of all the discoveries related to the pyramids, one of the most revealing is not a stone tool or a wooden machine. It is a piece of papyrus, aged, fragile, filled with notes in hieratic, the cursive script of Egyptian administrators. It is the diary of Mera. Mera was a foreman, an inspector, and his diary, dated to year 27 of the reign of Pharaoh Khufu, doesn't talk about miracles or divine secrets. It talks about deliveries, about work shifts, about bread and fish. This document, found in the port of Wadi al-Jarf on the Red Sea, is a snapshot of the most complex machine of all, organization. It shows us, day by day, how the Great Pyramid was fed. And the answer, once again, lies in water. Mera commanded a team of about 40 men. His task? To transport high-quality white limestone blocks from the quarries of Tura on the other side of the Nile to the construction site in Giza. And how did they do that? With boats. The diary details round-trip journeys. We transported stones from Tura. We loaded the boat. We sailed downstream. It is bureaucratic, and that is exactly why it is genius. They didn't depend on dragging everything over land. They used Egypt's vital artery, the Nile. But Giza is on a plateau, set back from the riverbank. There enters another engineering feat almost as impressive as the pyramid, an artificial canal. Archaeologists have found evidence of a large canal or port basin that came from the Nile and reached the foot of the Giza plateau. The boats, loaded with up to 20 or 30 blocks each, sailed through this canal. They reached a transshipment port just a few hundred meters from the base of the construction. Only then were the blocks transferred to the sleds, the sand was moistened, and the final journey by land began. Mera's diary mentions opening dikes to control the flow of water in this canal, showing active management of the water resource for logistics. This transforms the image we have. The Giza construction site was not an isolated and dusty place. It was a busy port hub, a constant back and forth of boats unloading stone, wood, ceramics, food. It was an operation that ran like clockwork, synchronized with the Nile floods, with the seasons. And what fed this human machine? The excavations in the workers' villages mentioned at the beginning answer. Bread. Lots of bread. Industrial bakeries were found, capable of producing thousands of loaves of bread per day. Beer, which was liquid, nutritious and safe food. Dried fish from the Nile. Beef, probably for festivals or for the foreman. This supply network was continuous. No one worked on an empty stomach. The diary of Mera is final proof that the construction was a state, civil, organized enterprise. There is no mention of slaves. There is mention of teams with names, working in shifts under the command of an official who reported to a minister of the pharaoh, Ankhaf, half-brother of Khufu. It is pure administration. This is the seventh and perhaps greatest machine, the bureaucratic machine. The machine that planned the routes, stocked the abrasive sand, kept the copper tools sharp and replaced, and guaranteed that yesterday's fish was on today's lunch table. Without this invisible machine of planning and execution, all the others, the seesaw, the rack, the elevator, would just be good ideas, never realizable. So we have come a long way. From the deconstruction of the slave myth to the revelation of a society that mastered water, sand, wood, and above all, human organization to achieve the impossible. But this leaves us with one last question, one that remains echoing after knowing these 7 wonders of practical engineering. What does all this mean for us today? What do we learn from these ancient masters, besides admiring them? The answer perhaps lies not in the stone, but in the mind that shaped it. So, here we are. After this journey through ramps, pulleys, wet sand, and logbooks, what remains? What do these 7 machines, social organization, the hydraulic elevator, the pinion and rack, the sled on wet sand, Herodotus's seesaw, abrasive saws, and the logistics machine, have to say to us here on the other side of more than 4,000 years? The first lesson is about humility. For centuries, the West looked at the pyramids with a certain superiority. They didn't have wheels, they didn't have iron, they didn't have cranes. It must have been brute force, pure slavery. Modern archaeology has turned this perspective upside down. They didn't have our technology, but they had an intelligence applied to their environment that was, in many ways, more sophisticated than we supposed. They didn't fight nature, they collaborated with it. Water was not an obstacle, it was an ally. Sand was not friction, it was a tool. This is deeply ecological thinking, long before the word existed. The second lesson is about human capacity. When we undo the myth of slaves dragging blocks, we do not diminish the achievement. We humanize it. Instead of an anonymous and suffering mass, individuals emerge. The foreman Mera, noting his travels, the mason who mastered the cutting of granite, the worker who poured the jar of water on the sand in the exact measure. It was the coordinated, specialized, and, to some extent, voluntary work of thousands of people that raised this. It is a testament to what a society organized around a common purpose can achieve, whether a divine purpose or a state purpose. And the third lesson, perhaps the most important for anyone interested in the intersection of faith, history, and science, is about caring for narratives. The story of Hebrew slaves building pyramids is a powerful narrative of liberation, but it is a cultural fusion, a metaphor that's solidified as fact. Archaeology invites us to a more nuanced reading. It doesn't cancel the Exodus, it replaces it in its probable time and space, centuries later, in works of brick, not stone. Separating this is not an attack on faith. It is a rescue of historical precision, which can, in the end, strengthen our understanding because it deals with evidence, not just traditions. The pyramids, in the end, are not an insoluble mystery. They are a puzzle we are slowly assembling with each new excavation, each new study of applied physics, each deciphered papyrus. They were not built by aliens, nor by a lost technology of magic. They were built by exceptionally intelligent, patient, and organized human beings. The true legacy of the pyramids, therefore, is not the stone that lasts. It is the demonstration that the limits of the possible are much wider than we imagine. That with keen observation, with practical experimentation, and with a collective will, it is possible to transform the material world in ways that seem, at first glance, miraculous. They whisper to us, across the millennia, that the greatest machine of all is not in museums. It was, and is, in the human mind, in the capacity to see, in a grain of sand, the lubricant for an empire, and in a simple jar of water, the force to move mountains. If you enjoyed traveling with us through these stories, through these 7 machines that defy time, subscribe to the channel. It's free, and by subscribing, you won't miss the next episodes, because there is still much the Earth holds, and science is just beginning to unearth. New theories, new discoveries at archaeological sites all over the world. Hit the bell so we can continue this conversation. Tell us here in the comments, which of these machines or discoveries surprised you the most? Was it the simplicity of wet sand, the boldness of the hydraulic elevator, or the human revelation of the Diary of Merer? We read all the comments and love to know what you thought. Share this video with that person who also loves a good history mystery. Until the next excavation.